Alright, similar figures. Two shapes are similar when corresponding angles are congruent. The two red angles that just appeared, they both have the same measurement. They correspond with each other. The blue angles that are marked with double arcs, those also correspond. They have the same measurement. The green squares, they're both 90-degree angles. They correspond with each other. So all of these angles are congruent, and that means that these triangles are similar. Also, the sides, the corresponding sides of these triangles have to be proportional. That means when you compare the corresponding sides, they're all going to break down to the same fraction. So we're going to give you some measurements. We've got 5 to 10. Those two sides correspond. 11 to 22. Those two sides correspond. 8 to 16. Those sides correspond. We're going to set up some fractions here. We're going to compare small to big. We're going to compare 5 to 10, 11 to 22, 8 to 16. And when you set them all up, when you look at all of them, they all break down to 1/2. So therefore, these triangles are similar. All the angles match up, and they all break down to the same fraction. They're all proportional. Are these two triangles similar? Looking at them, they almost look like one is a mini version of the other, but let's look at some measurements here and see if all of the corresponding sides are proportional. We've got 9 to 6. Those are both the smallest sides of each triangle. We've got 15 to 10, and we've got 20 to 12. This time we're going to compare the big sides to the small sides. We'll look at 9 to 6, we'll look at 15 to 10, and we'll look at 12 to 20. So we've got 9 to 6. Well, in lowest terms, that would work out to 3 to 2. Let's look at 15 to 10. That also works out to 3 to 2. So far, it looks as if these two triangles are similar. With that last fraction, though, wait a minute. 20 to 12 breaks down to 5 to 3 in lowest terms. So this one, just by looking at that proportion there, 20 to 12 is equal to 5 to 3. Does that break down to the same thing as the other two? It does not. So therefore, no, these triangles are not similar. Are these two triangles similar? Well, just looking at it, almost looks like they're not, because one's kind of twisted around. The smaller triangle's pointing in a different direction, but let's look at some numbers here. We've got 16 to 4. Those are each the smallest sides on each triangle, so those are corresponding. We've got these other sides, 36 to 9 and 44 to 11. So when you set up your big to small, you could have done small to big, doesn't matter. We're going to set up 16 to 4 because those are both the smallest sides on each of those triangles, so they correspond. Then we'll set up the middle sides, 36 to 9, and finally 44 to 11. And if you look at them, let's see, they all break down to the same thing. They all break down to the same thing, so that means they are all proportional. So therefore, yes, these triangles are similar. Proportions and similar figures. Setting up proportions for corresponding sides of similar triangles and naming the similar triangles. What we're going to do here is look at all the different sides that correspond. Notice how our corners of the triangles, the vertices, we are putting letter names to them. So we've got side A, B, and ED. So this time we're going to compare small to big. Do you see how ED is up top and AB is in the bottom of our setting up our corresponding sides? So then, do you see how DF will correspond with BC? And side EF will correspond with AC. Also, we can look at the angles. Angle A will correspond with angle E. They'll have the same measurement. That's why they're marked in the same way. Look at angle B and angle D. They're both marked in the same way. And then finally, angle F and angle C are also marked in the same way. So when naming these triangles, we have to name them by their corresponding corners and angles. You would call this, you could say triangle ABC is similar to triangle EDF. Notice how A and E are the first pair of points listed. B and D are next. C and F are the last ones. They're named by their corresponding corners. A lot of kids would want to just use alphabetical, and sometimes you can, but in this case, you cannot say that ABC is similar to DEF because A does not correspond with D and B does not correspond with E. C and F correspond, but those other pairs do not correspond. So you can't say that ABC is similar to DEF. Naming corresponding parts with no picture. So using the description below, we're going to answer some questions. So they tell us here that triangle LMN is similar to triangle XYZ, but they don't give us any pictures for this problem. But based on what I just told you in that previous frame, you should be able to figure these questions out. First, they're going to ask, angle Z is congruent to what other angle? Well, Z is the last of the points in the XYZ triangle, and N is the last of the points listed in the other triangle. So angle Z corresponds with angle N. Side LN will correspond to which side? Well, looking back in the original description, we've got LN corresponding with XZ. L is the first, N is the last, X is the first, Z is the last. So side XZ corresponds with side LN. And then finally we've got side XY. Well, XY is the first pair of points, so the first pair of points in the other triangle is LM. And that's about it.